Welcome everybody to another functional open science skill for AI and ML applications workshop series from the U of A Data Lab for the spring 2025. Today we're going to be talking handling images and videos part 2, and it's a continuation from what we have seen last week on getting a hold of and understanding how you can apply AI and ML to the world of images and video handling, or excuse me, images and videos in AI. Just wanted to check here a second. If this is your first time being here and want to know a little bit about the rest of the series or past iterations and watch recordings, please go to the following link, which is github.com, UA Data Lab, FOSS, AI, ML, Wiki. Here is where you'll find all of the content from this series, as well as other series from the U of A Data Lab. And for today's material, go down to 225, where you're going to find handling images and videos, and you can click on that material button. If you want to go and if you want to go there directly yourself, please follow the link here in the chat. So this is a follow-up of last week, handling images and videos, part 1. Going for a very quick recap, last week we looked a little bit at the architecture of CNNs, how they work, try to simplify it as much as we can in order to have it in a formula that we may be able to understand without going into too much details. We learn a little bit about what the feature learning step was and what the classification step was as well, and when you give it an image, sort of what happens between the input and the actual knowing what the input is. We did also ran through a small example, and my hope for today was the one to actually carry out a larger example using Cybers, but we are having some GPUs issues in the Cybers platform, so we'll have to either scale back onto your computer or run it on Colab. So therefore, I have a small little Colab window open, and I'm going to send this to you simply because some steps take a little bit of time. So we can run through things in just a second. With that in mind, it is in the chat right now. With that in mind, I wanted to start with a quick question. Do you know about what segment anything is? That can be in the chat. You can give me a thumb up or an X, or for Hari that is in the room, Hari, you can tell me I've heard of it or I've not heard of it. I'm not going to show it to you until you give me a proper yes or no.
What I understood is basically like drawing the boundaries of an object.
But do you know what segment anything is? Well, not just segmentation. You don't know. So you've never heard of segment anything. Fantastic. That's okay. I can take it from there.
Is it to segment for example, a dog or some person in the image to identify them one by one?
Segment a group or an image. That so you're not wrong. You are essentially describing what segmentation is at this point, which is not wrong. But segment anything is actually something that Meta has created, and this is what I wanted to for you guys to work through today, but we're not going to get to that simply because the GPUs aren't responding very well. And I'm going to copy this and put it into the chat. And I wanted to start with this because it's one of those easy things that you can press through. And this has been, this is something that Meta has been working on. And by what you say, Jorge, it's very much a trying to identify exactly what is in an image or a moving video. So if you go to demo and you read and accept everything, you're going to get to a number of examples here. And let's look at horses. We were talking about horses last time around. What you can do with this specific image is if you hover over it, you will, well, the segment everything will pick up on what this is, and you are picking up on a cloud right now. Sorry, on the sky, and then you can pick up on the cloud. You can pick up on the mountain. Pick up on also each singular individual horse, which is exactly what you were mentioning. But do notice how quickly it was to pick this up, and it's probably because it was pre-trained. Let's see what happens if we were to upload a photo. So give me a second here. And I do suggest you try to do the same. You probably have a bunch of photos lying around, so why don't you try it out as well? This may be too big, but let's try it. Okay, I am uploading a photo, and this is a photo from a gathering that we had last year for dendrochronology. Let's see what segment anything does for us. What is this? Cut out the object and multi-track. It doesn't know what it is, but it just is able to figure out what it is at this specific point. Let's see how granular it gets to with people. Oh, wait, hold on. Remove area. Remove area. We're removing this area right now. Let's do everything. Try to do everything right now. Final points after deduplicating. Ooh, oh my gosh, there we go. Wow, look at that. It is able to segment everything in this specific photo, and it took us just a few seconds. Let's see. Let's pick up on a person. I guess you can't do it right now, but what you can do with segment anything, it's to ideally take any photo and have it deploy its segment everything onto a specific photo, and it's so very, very, very quick. The idea from today was to have a small little demo running where with the camera we will move around, and it was able to pick up on me, my hand, or someone else in the room and tell the difference in an extremely quick method, or in an extremely quick amount of time. So if you've never heard of segment anything, I do suggest you try to look a little bit into it. I am gonna get extremely ahead of myself, but if you do scroll all the way down to today's topic, there is a small little tutorial on how to deploy it on your computer if you're interested, and I did paste it into the chat for today. So with that said, I've had to switch to a collab, which we're going to get to run right now. And it's important that we are going to start early because it just takes a while. So we're looking at a tool called Deep Lab Cut. I'm going to explain in just a second what this does. but essentially we are going to be following this poor little mouse that is stuck on a treadmill. So we will have to install a couple of things on Colab, and how you're going to do that, you're going to scroll down and just follow the instructions. So the idea is to follow the mouse and to track all of the tail and the eyes or the head. So that's the goal of what DeepLabCut can do. And so first, go to runtime, change runtime type, select Python 3, and then select GPU. Runtime is right over here. And then yes, no problem. Let me send you the link once again. I'm gonna put it into the chat for the people that were not able to follow. Okay, runtime, change runtime in Python 3. Runtime, change runtime type, Python 3, and T4 GPU. You're gonna click save. And for the first box over here, click go. It is just going to install a couple of things and click run anyway. Let's see if it gets, all right, it is getting connected. So let's let that run for a while. This is gonna take a little bit of time. Let me close last week workshop, and we're gonna talk about handling images and videos part 2. So with last week, we talked about how CNNs or convolutional neural networks work. And there is a little bit of things that I did not really cover last week. For example, we didn't really talk about applications and how in today's world we are applying CNN models. I have taken a couple of these models and I wanted to show them how we are applying them into the scientific world. And what I find a little bit intriguing is that it isn't really the laboratories that are looking into the CNN that are taking these tools. It's very much the biology labs or the chemistry labs that are taking these tools and making them into or applying these into their own science. And therefore, I looked a little bit into what examples I could pick, and I did work on containerizing this tool called DeepLabCut, available for Cypress, that we can't use today. But here are a couple of examples that you may be interested in seeing how these CNNs are being used in the world of science. The first tool that I did want you to keep in mind is DeepLabCut. And here is a small little GIF that they have recorded about what it can do. And DeepLabCut is an open source deep learning based software designed for pose estimation. Before I continue, does that make sense what pose estimation is? Pose estimation is essentially figuring out what an object or a person or an animal is doing. For example, let me put this straight a second. If I were to just stand here, pose estimation will say, I am standing, I am waving, I am walking. So that's what pose estimation can do, literally estimate your pose. So pose estimation can be applied to the research of animals. It can be applied to how cells talk to one another. And it can be applied also to how humans behave between each other or with a computer. DeepLabCut is a successor of a software called DeepLab, released in 2016, that was used that uses deep learning framework as a ResNet, sorry, that uses ResNet as its backbone architecture. like a lot of other CNNs, it uses the pre-trained models on large image data sets, and it refines them using user-labeled frames from precise key point detection, very similar to what is going on in the GIF above. So I'm not going to go into too much details about Deep Lab, but Deep Lab Cut has a number of applications. Actually, this GIF is from it, and also this GIF is from Deep Lab Cut as well. So in the past, the Deep Lab Cut was used for tracking single animals, and there was a bit of an attrition, because if you want to look at a herd of sheep, for example, you would have to figure out other ways. And that is where sleep came in. What you're seeing here is the behavior of first two mice on the right, and then two Drosophila flies on the left-hand side. And sleep took where Deep Lab Cut was lacking. So sleep was able to follow multiple animals or multiple insects together. And for doing so, it needed multiple models, a top-down model that first detected the entire animal and then estimated its pose, a bottom-up model directly directing key points across all animals, and use a full convolutional network for segmentation approaches. And we're back to ResNet, and in this specific case also HRNet architecture for feature extraction and pose estimation. So Sleep tried to do what Deep Lab Cut couldn't, which was follow multiple animals. Deep Lab Cut came back with, we actually can run multiple animals right now. So between the two, if you had to choose between which software to use, I would say to use Deep Lab Cut. So this actually is a good segue into going over here and trying to run our collab again. Notice that after installing a few things, it asks us to restart the session. So please do restart the session, because what this does is essentially making sure that everything is installed. So just for funsies, I'm gonna click play again. It should tell me that everything is already installed, and it did. So I'm gonna install the next thing, which is storage. We're gonna go and press play. And now hopefully this is a little bit quicker. Let me see how quickly it goes and the installation goes as well. Okay, so Torch is now going to install. Let's leave it alone once again, and let's go to the notes for today once again. Oh, I did put links to both, by the way, Deep Lab Cut and Sleep, if you want to go ahead and check them out. The collab for the day you can find within Deep Lab Cut, the Deep Lab Cut GitHub. And the reason why I'm also sharing this with you is because you can also look at finding more information about how these things work. But I don't want to get ahead of myself here and lead you to wrong holes. It's up to you whether you want to know more about it. But this is the reason why I'm talking about it, is because there is somebody that earlier had approached me asking me, okay, I want to know more about applications and where I can essentially apply the knowledge that I've gained in CNNs for a job, or for a part-time job, or for an RA ship. And the reason why I'm showing this is because, look, if you want to have a job, don't go for pure mathematics or look into making these models quote unquote better. Look at applications and laboratories that you may be able to apply this in. And therefore, Deep Lab Cut and SLEES are two great options for you to apply if you're able to find an opening for an RA ship in a biological laboratory. So take that, run with it, go find a laboratory that's looking for applications. Carlos did post a link. Let me open that up. And we're talking a little bit about deep learning pose estimation. There we go. Carlos has an entire. Oh, we also talk about sleep here? Damn. I am surprised because I did not know this page existed. So I am sorry, folks. It feels like someone else has already kind of wrote part of today's lecture for me, but I'm too late. So I'm gonna go back to Colab because we are able to run the next cell. Don't worry about the error, we just move on. Hopefully everything's gonna be okay. So I'm gonna press play for the next one, and what we're doing here is that we're simply creating a link, a syn-link to the NVIDIA libraries, and that was quite quick. And now we're going to clone the DeepLabCat GitHub repository. This ideally shouldn't take long. Seems like it's through. Cool. So what we did is we downloaded things that we needed. We got into the right repository, and what does it say? Warning, you are connected to a GPU runtime, but not. Don't worry, I'm going to be using the GPU. Okay. We're gonna go into another folder right now and going to install things that we require. So hopefully this won't take too long. And whilst this runs, I'm gonna go back to the lecture for today. So we looked a little bit about the of applications of CNNs, but now I want to change gears a little bit because I want to talk about the Swiss Army knife. And the Swiss Army knife is resources for the bigger picture, resources of what we are going to be using going forward. We're not going to be looking at DeepLabCat after today, hopefully, or sleep. We're going to actually be looking at YOLO. How many of you have heard of YOLO? You haven't heard of YOLO. Anyone online has heard of YOLO?
Yes, it's an object detection algorithm model.
Okay, yes. Can you tell me more about it?
So it basically identifies different objects. It is being trained on usual day-to-day objects, as in a pen, a register, a table.
Okay.
Like you look at, and the basic behind that YOLO model is that you look at every frame just once. So it's not very highly accurate, but it kind of does the job with normal day-to-day objects.
Cool, fantastic. So you can use YOLO. Tanish, thank you very much for the explanation, but you can use YOLO outside of things that you just described. And I'm not saying that you're wrong, because you're actually right on the second part where you were saying that it might not be as accurate, but the difference between YOLO and You Only Look Once, by the way, that stands for You Only Look Once, and a lot of other CNNs is the speed at which YOLO works. So I did not want to rewrite an entire documentation on YOLO because there is a lot of information, excuse me, available already. So I'm going to open the DataCamp link that exists over here. And because there is a couple of images that I want you to look at. Why is YOLO so fast? And why is it good? So the way that I am understanding how it works is, let's look at this picture right here. There isn't actually much of a difference between this and what we were looking at last week. Let me pull that image up. There isn't that much difference between the image that they have in the YOLO paper and the CNN quote unquote classical way of classification. But there is one thing that is quote unquote missing, and that is the part of the classification. The way that I am understanding it is that classification, when with YOLO, actually starts in the convolutional layer upstream. And if there is anybody in the room that is picking this up or is picking up on this and probably knows that I'm wrong, do let me know. So if the convolution or the classification happens upstream, how does that actually work? And we have a couple of images here that will help us understand what is going on. So during normal classical during classical CNN, what would happen is that an image is broken down into boxes, let's call it multiple boundaries. And what it will do is that for each boundary, it will do multiple passes, first gathering information on what is within the bounding box, and then going back to it and classifying it as needed. However, what YOLO does is that it cuts out, it trims the fat essentially, where instead of going through every single box first and then going back to the box itself and classifying it again, what YOLO does is that it does it as soon as the box is bound. So over here, recognize that it's just pitch, then it moves on, it's just pitch, it's just pitch, it's just pitch. There is something, and it recognizes what is significant and what isn't simply by merging two of the techniques that would be slowing things down otherwise. So let me scroll down a little bit. Whilst this happens, so whilst it is able to identify what is inside the boxes a lot quicker, it is also able to identify what is within an object and classify the different objects within that specific frame. So in a sense, why is YOLO so quick? Is because it is able, or it's because it takes a number of techniques that usually will take more time because that's just their standard of procedure, and merges them into a single pass. And I think, if I remember correctly, that is called a single pass learning. Single forward pass, excuse me about that. So a comment from Tanishq earlier was also that, well, it is fast, but there is a drop in quality. So let's look at it and let's go back, and there is here we're looking at actual applications, but there is a couple of graphs that I wanted to look at. So because of how quickly YOLO is it can take FPS frames, essentially frames per second for the ones that don't know, and apply its method on it. And in the beginning, YOLO, we're looking at YOLO v3, it wasn't as accurate as other algorithms here on the left. But as we progress, and we're looking at YOLO v4 right now, it is a lot more accurate than YOLO v3. And if we were to look at where we are today, and I think there may be a graph in here that explains it. We were looking at YOLO V7, which is a lot quicker, once again. But essentially, we are at YOLO V11 now. And YOLO V11 is both quick and accurate. So yes, YOLO is quicker and might be less accurate than your average CNN or CNN, but it is getting a lot better. And with how fast it is, we're looking at an algorithm that is fast and also reliable. I know that there is a couple of people in the room that are a couple of experts and might have looked at YOLO before. If there is some things that you want to say that maybe you want to point out that I am wrong, or there is a couple of things extra to say on YOLO, go ahead, unmute yourself, because I wanted to keep it simple when I was explaining what YOLO is. Meanwhile, I'm gonna take a sip of water. If there isn't anything, you can read the paper on YOLO. I have linked it here in the documentation for today. Or you can read the articles that are from DataCamp and Medium. They go in a lot more depth about what YOLO is. So with that in mind, I would like to go back to our collab, where we have to restart the session once again, and this is part of what we are supposed to do. So I'm going to restart the session. Do not worry about the errors. Hopefully, do not worry about the errors. And now we're actually able to run things. I'm going to click import deep lab cut. It's taking a little bit of time. So whilst this loads, it's important for me to say deep lab cut comes in two flavors. One is a GUI flavor. And as a GUI flavor, you're able to gosh, does it have an image here? You're able to point and click, essentially. It does not have an image, but you're able to point and click where things are. And the second flavor is pure command line, or Python in this case. And that is actually the one that we are running right now. We imported the black cut. We are going to create a variable from the config file, and we are going to load the data. That was quick enough. So here we're going to start the training for the deep lab cut network. I strongly suggest you change this number from 10,000 to 1,000. And the reason why that is because obviously we are running on Colab and things are slow. If it runs for 10,000 matrices, it's just going to take forever. So we're going to drop it down to 1,000. I did try this out yesterday, and I strongly suggest you go with 1,000. So we're going to press play, and we're going to let this run now for a little bit. So you're going to find that if you scroll down, essentially, soon it's going to start going through the different iterations. So let this run for now. Okay, so if we are going to if going forward and throughout tutorial, we're going to be using YOLO, we also have to start thinking of the rest of the infrastructure that we need for our for making things work. And one other important piece is Ultralytics, and Ultralytics is the company behind the maintenance of YOLO. They are proprietary, meaning that YOLO belongs to them. Sorry, I did not mean to open that. YOLO belongs to them, but they also make YOLO, I think, V5 available to the public, but they are the ones that are maintaining YOLO V11. So it's gonna take a while before we get to maybe using YOLO V11 as we require. We do require Ultralytics in order to run YOLO, and that's why I need to present it. It does most of the heavy lifting, which is talking between YOLO, the rest of the computer, and the training itself. You do need to have PyTorch installed, and for people that might understand hardware, what this means is you require, hopefully you don't, but it's a lot easier if you have an NVIDIA graphic card. So that is a hard requirement. If you're able to work on an AMD card, fantastic, but you do require PyTorch, which means that you might require NVIDIA. In order for us to visualize things, we require Gradio. Gradio is a Python library that allows you to create a web app, essentially. I think it does have a couple of examples here where, you know, you import Gradio and you have a very short code that output a small box where you can input your name and let's see what happens. Michele, submit very quickly. It says hello, Michele, and the code is just right here. And that's super quick. You can look at, for example, Airbnb maps around New York City, and this is something that you can go ahead and build yourself. So the only reason why I'm mentioning Gradio right now is because it is something that we're going to be using going forward. So this is not ML. This is a tool that you can use. We're also going to be using OpenCV, and if you are familiar with OpenCV, well, I'm not surprised. It's a little bit like the elephant or the dinosaur in the room. I think it's been here since at least the late half of the 1990s, if not early 2000s. And the reason why we need OpenCV is just to output images and videos. So the reason why I'm putting this out right now is because if you have time in your own time, play with it. Play with Gradio, play with OpenCV. Go to learn a little bit about YOLO, see if you can apply it yourself on your own research. So this is just information that I'm just sharing with you. So this is actually a good time to go back to our Colab because we have finished training our small little model. Fantastic. And I've never really shown you the files and whatnot, or the exactly the files and whatnot, but we're looking at mice on treadmills. So I'm sorry I'm getting ahead of myself over here, but we can now go ahead and start evaluating. You can read exactly what is going on right here. For us, we can just go and press play. This function evaluates a trained model for a specific shuffle or shuffles at a particular state of all states on the data set and stores the result as a CSV file. So as you understand, because we talked about it in the past, what we're doing is essentially we're looking at a particular behavior and we are transforming that behavior into code, or not code, but data that we can look at. Cool. That was very quick. Let's scroll down. We could look at the images if we wanted to. There is no reason for us to at the moment. And now we can start analyzing the videos. So we went through the images. Now let's go through the video. It will take some time, so it is good for us to get going right now. Just gonna press play. and let this go. It's gonna take some time. So we can go back and look at today's discussions. What is the next thing that we do require, or this the thing that we require beforehand, before we actually start, before actually starting to training a model? I'm cheating over here, or you could be cheating over here, because what we need is annotations, and annotations are extremely important. I want to talk a little bit about two websites here, but for the folks in the room, what are annotations? Marking the things in an image. I'll take that. You know what? I'll take that. How do you do it?
Is it like labeling? We label
Yes,
it.
but how do you do it?
Okay.
Oh, previously, I don't know if I did it correctly. I just highlight a box to highlight the area for the CNN model.
Yeah, that is essentially what how you do it. And what program do you use?
I just
NumPy and
use-
OpenCV.
Excuse me, one at a time. Let's go with Tanishq, since you were the loudest.
I guess NumPy. We
You use,
use
okay, interesting. Hoike, what did you use?
I don't know the concept, so I just draw a box on top of my image and shape it to red color so the CNN model can notice is something different.
Okay, all right, cool. Interesting. So hold on a second. I'm gonna go back down. My legs are getting tired. So I wanted to present to you a couple of tools that may make annotations easier for you. And the first one is RoboFlow. If I were to open RoboFlow right here, it will ask me to sign in. But RoboFlow is an application that essentially allows you to take some time and label images for your annotations. And here I have a set of 141 bean images, and I'm pretty sure this is something similar to what Hoike was doing, which is you take a picture of something, or you're given a picture of something, and you are creating an image, and each object is given a label. Is that what you were doing, Hoike?
Oh, yes.
Yeah. So the thing is, this is honestly what takes the longest. We had to hire an undergrad to go through, I think, 300 images, not of beans, but of charcoal rot, which is a disease in plants. And what we're doing right here, if you think about it, we are taking an image, and what we're doing is telling it where things are. We're telling it where things are and what they are. And if you think about it from a computational perspective, from an image perspective, this is just saying, oh, the pin to bean is going to be at location X and Y with this much, and whatever it's in within this box is what a pin to bean is. So the more you do it, the more you have the ability to recognize pinto beans in different occurrences. In this specific case, you have a pinto bean and you also have a kidney bean, but also what's important is what is between the pinto bean and the kidney bean, which is a little bit of overlap. So when you're running a real model, that overlap, that example will become extremely important. And the reason why I wanted to bring RoboLab up is because it's easy. You create an account, you upload a number of images, you create these labels, you download the annotations, and you're able to use these annotations to train your own model.
So
The same,
can I add a question?
yes.
So I will be working on some medical images. So the problem with my box annotation is I'm looking at the MRI of a spine. So it's very curvy, and there are a lot of structure very tight to each other. So I find it hard to label that with a box. So
Yeah.
are there like multiple ways of annotating?
So there is so yeah, it is not just enough to do a box, that's for sure. I remember another labeling tool that you could actually create multiple points around, for example, the bone. Let me get back to you with the name of that tool, if that's all right.
Yeah, thank you.
No worries. This will be in just a moment. Let me finish up what we have going until for now. And if you could stay just a second, Hoike, then I think I will be able to find that tool for you. There is something in the chat. Ah, yes. Okay, no worries. Okay, so Label Studio, I don't need to open it up. I wouldn't want to open it up right now. It's the same thing as RoboFlow. If we're just looking at squares or putting things in square, Label Studio is a great it's a great option as well. Label Studio is a little bit more open source, meaning that you don't actually need to create, it's non-proprietary, so you don't have to go ahead and create an account for someone else. You can literally run a Docker container and run the Annotation Studio on your laptop or your machine. So with that in mind, I wanted to go back over here because we should be close enough. So I'm going to create the label video. So it all ran. It all ran through the analysis. We're now having to create the labels and to plot the trajectories. And this is gonna take a second. I'm gonna pause here. Oh, no. It's free to go. Okay, it's done. It's telling us to go to content, clone, DLC, repo, examples, and opening up the MP4 and data. So let's go and see it. Gonna open up the files, going to clone DLC repo, examples. Oh gosh, I hope I'm going to the right way. Colab, not here. Jupyter, not here. It's gonna take a second, folks, just a second. Test. Sample data. Oh gosh, no. The reason why I'm taking some time here is because I got lost yesterday trying to look for the output files. I'm pretty sure that it was in my, it's in content, examples, right? Examples. Open field. Oh. Videos, plot poses. Okay, cool, fantastic. The output is not a video, and so this is not going to be as fun for certain folks, but let's look at it. I have a trajectory.png, but let's look at that. What essentially was able to create, it was it was able to map the tailbase, the left ear of the animal itself, of the mouse itself, and create the entirety of where the mouse went throughout the video. We can look at the plot as well of the some extra information of extrapolated from the videos, and maybe, just maybe, there is something in here that may be helpful for what you want to do. Maybe it is not exactly what you require for your research, but I want to just say that there is tools out there that if you're working in biology, if you're working in chemistry, there are tools out there that will require your services going forward. There is, I wanted to look at, yeah, let's look at this one right here. I did download it. Wonder if I can share. Ah, there it is. And here we have the entire video of our little mouse. And what you're seeing is the labels going through and following the mouse, where we then were able to create our own little labeled graph. So I'm not going to look for the entire minute of the video right here, but I did want to mention the ability of certain tools to do exactly what scientists will need to do, just quicker and better. So, with that in mind, I am coming to an end of today's workshop of how to handle images and videos. We looked at a couple of the applications for what you can use CNNs in science. And we also looked at the tools that we're going to be using going forward. So with that, I wanted to ask whether you do have any questions regarding today. And if you don't, by all means, look at the tools that we're going to be using. Try to think of ways that you may be able to use these tools together, because that's how we use them. And next week, we're going to be looking a little bit in depth on training and testing and how it works. So with that in mind, thank you very much for your attention. It's always fun coming in here and learning things together. Hoike, please hang back. For everybody else, I'll see you around.